Welcome to the deep dive. Today, we are setting our sights on something pretty massive. We're talking about the Milky Way galaxy,
That's right.
100 billion
A
stars.
little big one.
It's pretty mind-boggling. How are we going to even wrap our heads around this?
Well, it is mind-boggling to think about the sheer scale.
I mean, 100,000 light years across.
Yeah.
Just to cross the Milky Way at the speed of light would take 100,000 years.
You know what, though? It really puts things in perspective, doesn't it?
Yeah.
That we're actually a part of this grand system.
I know. It's like we're on this cosmic joyride.
Yeah.
Where do we even start?
Well, the best place to start is at the heart of it all, the galactic core.
Lead the way.
It's a place shrouded in mystery, but we're starting to unravel its secrets.
Okay, so what's lurking at the center of our galaxy?
Well, picture this as a supermassive black hole
Wow.
called Sagittarius A.
Catchy name?
Yeah.
Oh.
With a mass 4 million times greater than our sun.
It's hard to even picture that.
It's squeezed into a relatively small space, though, and you can't actually see a black hole directly.
Right, because the gravity is so strong that even light can't escape.
Exactly.
So how do we know it's even there?
Well, we can see its effect on the stars and gas clouds that are orbiting it.
Oh, okay.
They're whipping around Sagittarius A at incredible speeds.
So you can see its influence, basically, even though you can't see it.
Exactly. It's a dead giveaway that there's something massive there.
So it's like the puppet master of the galaxy, in a way.
It is. It's the glue that binds the Milky Way together.
Wow.
Its immense gravity dictates the motion of everything, stars, gas, and everything in between.
Okay, so it's not just a black hole, it's the anchor of our entire galaxy.
Exactly.
Wow. So, okay, let's move outwards now from this central anchor to those iconic spiral arms that we always see in pictures of the Milky Way. What's going on out there?
Well, those spiral arms are bustling construction zones.
Oh.
They're stellar nurseries.
Yeah.
This is where stars are born. And massive clouds of hydrogen gas collapse under their own gravity. This creates intense pressure and heat, eventually igniting nuclear fusion at their cores. And this is what gives birth to brilliant new stars.
So those stars that we see twinkling out there, some of them are brand new.
That's right.
Wow. Now, where's our little solar system fit into all of this?
Huh?
Are we out there in one of those bustling construction zones?
Actually, we're in a relatively quieter area called the Orion Arm,
Okay.
about 27,000 light years from the galactic center.
Okay, so we're in the suburbs of the galaxy,
That's right.
out in the sticks. But we're still hurtling through space at some crazy speeds, right?
We are, yeah.
How fast are we going?
At 514,000 miles per hour
It's hard to even imagine.
as we orbit the Milky Way.
Okay, at that speed, how long does it take for us to make one full lap around the galaxy?
Well, that's what we call a galactic year.
Okay.
And it takes about 225 million Earth years.
I can't even.
That means, since the Earth formed, we've only completed about 20 orbits.
That's wild. That really stretches the concept of time.
Yeah.
It makes you feel like our planet is pretty young. But okay, let's zoom out even further. What's the Milky Way's neighborhood like? Are we alone out here?
Not at all. We're part of a larger group of galaxies called the Local Group.
Oh, okay.
It's kind of like our...
Seriously, what happens when galaxies collide? Like, what's going to happen to the Milky Way?
Well, it's not like a car crash. It's more like a slow gravitational dance.
Oh, yeah.
As they merge, their spiral arms will be disrupted and their central black holes
Right.
will eventually combine into an even more massive black hole.
So basically, it's a cosmic tango that ultimately leads to a brand new, even bigger galaxy
That's right.
that's both kind of terrifying and really cool at the same time. But in the middle of all of this cosmic drama, I can't help but wonder about those exoplanets we keep hearing about.
Yeah.
Those planets that are orbiting stars beyond our solar system. What have we learned about those? Are we alone in the Milky Way?
Exoplanets are one of the most exciting areas of research right now.
Yeah.
Thanks to missions like Kepler and TESS, we've discovered thousands of them within the Milky Way. And we're finding more all the time. And they're incredibly diverse. There are gas giants bigger than Jupiter. There are rocky planets like Earth.
Okay. So with all these exoplanets out there, I mean, what are the chances of finding one that could actually support life as we know it?
Well, that's the question, isn't it?
Yeah.
One key factor is what's called the habitable zone,
Okay.
which is basically the sweet spot around a star where temperatures are just right
Right.
for liquid water to exist.
Right. Goldilocks.
Exactly. And, where there's water, there's a possibility of life.
Yeah, it's a tantalizing thought, right?
It is.
To think that there could be other worlds out there, maybe even with life forms we can't even imagine. But okay, before we get ahead of ourselves, I want to go back to those stunning nebula. They really are like cosmic works of art, aren't they?
Absolutely.
So, okay, tell me about them. What are they?
Nebulae are vast clouds of gas and dust that are illuminated by the light of nearby stars. And they come in a dazzling array of shapes and colors.
Yeah.
They represent different stages in the life cycle of stars.
Can you give us some highlights, like the greatest hits of the Milky Way's nebulae collection?
Yeah. You've got the Orion Nebula, one of the brightest and most easily recognizable.
Yeah, I've seen pictures.
It's basically a stellar nursery
No.
where you can actually witness the birth of stars.
Wow.
And then there's the Eagle Nebula, which is home to the iconic Pillars of Creation.
Yeah, the pillars of creation, those pictures are incredible.
Yes.
What are they, though? What are we looking at when we see those?
Well, they're these towering columns of gas and dust, sculpted by the intense radiation of young, hot stars. And it's within these pillars that new stars are being born.
That's amazing. So they're not just pretty pictures, they're active regions of star formation.
That's right.
Wow. It really drives home the point that the Milky Way is a living, breathing entity.
It is. It's constantly changing and evolving over billions of years.
Wow. Well, this has been an incredible journey so far. We've gone from the supermassive black hole at the heart of the galaxy to the star-forming regions in its spiral arms. We've even touched on the possibility of life on other planets and explored the breathtaking beauty of nebulae.
It's amazing what you can find in our own galactic backyard, isn't it?
It is, but there's so much more to the Milky Way than meets the eye. I mean, all this stuff we've been talking about, it's just the tip of the iceberg.
Oh, absolutely. There's so much more to discover.
And so much we still don't know.
Yeah. And that's what makes it so captivating.
Right.
It's like this grand cosmic puzzle that we're slowly piecing together.
So how about we dive even deeper into this galactic puzzle in part 2 of our Milky Way deep dive. We've got so much more to explore.
Let's do it.
Stay tuned. Welcome back to our deep dive into the Milky Way. Last time, we left off talking about colliding with Andromeda. But for now, let's zoom back in on something I've always been curious about. Dark matter. It sounds like something straight out of, Star Trek or something. What is it?
Yeah, it does sound pretty sci-fi. And the truth is, it's one of the most intriguing puzzles in astrophysics. It's kind of like we can see it's there, but we can't actually see it.
Okay, that sounds pretty frustrating for a scientist. How can you study something that you can't even see? What's the evidence that it exists?
Well, think of it this way. Imagine you're watching a merry-go-round, at a park or a carnival, and you notice the kids on it are spinning much faster than the motor should allow.
Right.
That would suggest that there's some unseen force pushing things along, right?
Yeah, like some invisible horses or something just propelling the whole thing.
Exactly. And that's kind of what we're seeing in the Milky Way. The stars are rotating around the center of the galaxy much faster than they should be, based on the visible matter alone. So this suggests that there's a whole lot of unseen matter, this dark matter, providing that extra gravitational oomph.
Okay, so basically, dark matter is like the phantom horses of the galaxy, this invisible force driving the motions of the stars. And how much of this invisible stuff is actually out there?
Well, scientists estimate that dark matter actually makes up a whopping 85% of the total mass of the Milky Way.
Wait a minute, 85%. So that means everything that we can see, the stars, the gas, the dust, all that stuff, is only a tiny fraction of what's actually out there. It's kind of spooky, right?
It is. It's like we're just scratching the surface of what's really going on in our own galaxy.
So, okay, we've got this invisible force, dark matter, holding everything together. But where does it actually reside? I mean, what are we talking about here?
Well, a lot of it is thought to exist in what's called the galactic halo, this vast spherical region that extends way beyond the visible disk of the Milky Way. It's like a giant cosmic bubble that envelops the entire galaxy.
Okay, so it's like a giant invisible sphere surrounding everything we can see. That's pretty mind-blowing. But what's actually in this halo? I mean, is it just like empty space with this dark matter floating around?
Well, not exactly. It's not completely empty. The halo is also home to some of the oldest stars in the galaxy, relics from the Milky Way's early formation. And it contains these fascinating structures called globular clusters.
Globular clusters, what are those?
Imagine a giant ball of stars, hundreds of thousands or even millions of them, all packed together incredibly tightly. They're like ancient swarms of stars orbiting the galactic center like a swarm of bees around a hive.
Okay, so they're kind of like mini galaxies within a galaxy. It's kind of like a Russian nesting doll situation. But what can we learn from these globular clusters? Why are they so interesting to scientists?
Well, because they formed so early in the Milky Way's history, they're like little time capsules. Yeah. Studying them can give us valuable insights into the Milky Way's evolution and help us unravel some of its ancient secrets.
Okay, so we've got dark matter, ancient stars, and these incredible globular clusters all hanging out in this vast halo surrounding the Milky Way. It's enough to make your head spin, right? But, with all this talk of invisible forces and ancient relics, I'm starting to wonder if there's anything actually visually cool to see out there in the Milky Way.
Oh, absolutely. The Milky Way is full of visually stunning objects.
Okay, give me some examples.
Well, for example, you've got pulsars.
Pulsars, that sounds kind of cool. What are those?
Pulsars are actually rapidly spinning neutron stars. These are incredibly dense remnants of massive stars that have gone supernova.
Okay.
Imagine something with the mass of our sun, squeezed into a ball the size of a city.
That's almost impossible to imagine. So how do these neutron stars turn into pulsars?
As these neutron stars spin, they emit these beams of radiation that sweep across space like a lighthouse beacon.
Wow.
From our perspective on Earth, we see those beams as regular pulses of light, hence the name pulsar.
So basically, it's a cosmic lighthouse, blinking its light across the galaxy. How fast do these pulsars spin?
Oh, some of them spin incredibly fast, hundreds of times per second.
That's incredible.
And with every rotation, that beam of radiation sweeps across our field of view.
That's amazing. Okay, so we've got these pulsars spinning like crazy and beaming their light across the galaxy. And you mentioned supernovas before. So when a star goes supernova, when it explodes, it leaves behind these incredible clouds of gas and dust.
Yes.
What are those called?
Those are called supernova remnants. They're some of the most visually spectacular objects in the Milky Way. They're like cosmic fireworks, these beautiful displays of swirling gas and dust. Right. One of the most famous examples is the Crab Nebula.
Yeah, the Crab Nebula. I've seen pictures of that. It's just breathtaking.
It is, yeah.
It kind of makes you realize that even death in the universe can be beautiful.
Yeah.
Are there any other kind of must-see objects in the Milky Way's cosmic art gallery?
Well, there are also magnetars.
Magnetars. Okay, that sounds intense. What are those?
Magnetars are a type of neutron star, but they have these incredibly powerful magnetic fields, trillions of times stronger than Earth's magnetic field.
Trillions of times. That's pretty hard to even comprehend. What effects do those supermagnetic fields have?
Well, they can trigger these massive bursts of energy, releasing intense X-rays and gamma rays. They're some of the most energetic objects in the entire Milky Way.
Wow. So we've got these pulsars spinning at incredible speeds, beaming light across the galaxy. We've got supernova remnants painting the cosmos with their explosive beauty. And then we've got magnetars crackling with this unimaginable magnetic power. It's like the Milky Way is a cosmic zoo of exotic and fascinating objects.
It really is. It's full of surprises. And the most incredible part is we're constantly discovering new objects and new phenomena. There's still so much we don't know, so much more to explore.
Yeah, it really makes you realize how much is still out there waiting to be discovered. Well, unfortunately, we've come to the end of part 2 of our journey through the Milky Way. But don't worry, the adventure's not over yet.
Right.
We've explored the unseen realm of dark matter, ventured into the galactic halo, and encountered some of the most extreme and fascinating objects in our galaxy.
Absolutely.
But there's still so much more to uncover. We still need to understand the bigger picture. How did the Milky Way come to be? How has it evolved over billions of years? And what's its ultimate fate?
All great questions.
Well, we'll tackle all of those big questions in the final chapter of our Milky Way saga coming up in part 3. Stay tuned.
Welcome back. We've explored the Milky Way structure, its strange and wonderful inhabitants, but now let's step back and look at the bigger picture. How did this massive swirling galaxy come to be?
Well, to understand the Milky Way's origins, we need to rewind the cosmic clock about 13.8 billion years.
Okay, back to the Big Bang.
To the very beginning, the universe starts as this hot, dense soup of particles.
All right.
And as the universe expands and cools, gravity starts to pull these particles together. And that forms the first stars and galaxies.
So the Milky Way didn't just, pop into existence fully formed. It was a process.
Exactly. It started small. Clumps of gas and stars merging together over billions of years. And sometimes those mergers involved entire galaxies, a process we call galactic cannibalism.
Galactic cannibalism. Okay, that sounds pretty intense. So you're telling me that the Milky Way we see today is a product of these ancient mergers, like a mosaic of smaller galaxies that have been gobbled up over time. That's right. And this process is still ongoing.
Really?
Even now, the Milky Way is pulling in smaller dwarf galaxies, adding to its stellar population.
So it's like a cosmic recycling program. Old galaxies get broken down and their material is used to build new ones? That's pretty wild.
Oh, yeah.
But what about the future? We know that the Milky Way is on a collision course with the Andromeda Galaxy. What's going to happen to our galaxy after that?
Well, the collision, it's going to be a slow, drawn-out dance lasting billions of years.
Okay.
As those two galaxies approach each other, their gravitational forces will start to distort their shapes. They'll create these spectacular tidal tails of stars and gas.
I see.
Eventually they'll merge, spiral arms disrupted, forming this new, larger galaxy.
It's almost impossible to imagine something so massive transforming like that. But what about the stars and planets within those galaxies? Will they survive this cosmic shakeup?
Well, most stars will actually survive the merger relatively unscathed.
Oh, okay.
The distances between stars are so vast that direct collisions are incredibly rare.
Yeah.
But, the orbits of many stars will be altered, creating these entirely new patterns in the night sky.
So the constellations that we know today would be completely different.
Exactly. Imagine a night sky with new constellations, swirling patterns of stars unlike anything we see today.
Wow. That's mind-blowing. It's also kind of humbling. Our galaxy, our sun, our planet, all part of this vast cosmic dance. Constantly changing makes you realize how dynamic the universe really is.
It does, and it's a reminder that our understanding of the Milky Way is constantly evolving too.
Right.
New telescopes, new technologies. We're constantly probing deeper into the Milky Way's past, present, and future.
Unraveling its secrets. Well, we've reached the end of our epic journey through the Milky Way. We've explored its structure, its history, its future, and even touched on the possibility of other life existing within its vast expanse.
It's been quite a ride.
It has, and it really makes you realize how much there is still to discover out there.
It does. It sparks that curiosity.
Absolutely. So to all of our listeners out there, next time you look up at the night sky, remember, you're not just seeing points of light. You're looking at the edge of our own galaxy, a vast cosmic island teeming with possibilities. And who knows what future discoveries await us. Keep exploring, keep questioning, and keep looking up. And we'll be back soon with another deep dive into a new fascinating topic. Until then, stay curious.